Good morning, guys. This will be notes 3.13. Today we're going to be looking at graphing inverse functions. And there's two types of graphs, but we're going to focus on continuous functions. And we're going to be using the rules of transformations to graph. So coming back to, the topic from the last test where we had transformations and things like that. We're going to come back to that for this lesson. So let's look at graphing inverse functions in general, right? So it says the graph of an inverse relation is the reflection of the original graph over the line y equals x, as seen below. So this line y equals x is this line right here. This purple line that's dashed is the line y equals x. So if I were to draw this line, it's basically the diagonal of the x and y axis. We would notice that there are particular points there. So let me zoom in there. In a discrete example, if we were just working with points, right, I would ask you, what's the coordinate of this point that I circled? Well, you would say it has the coordinate -1, 3. But then if I switch them, we get this point that I circled in red, which has the coordinates 3, -1. So this is the original point, this is the inverse. But notice, how far is this point to the purple line? How many diagonals across is it? It's 1, 2. 2 diagonals, right? If I connect it with a straight distance. So how I'm connecting it is in the following way. How far does it take for me to get to this point? Is the same distance as it takes for me to get to the blue point. So these 2 points are the same distance to the line, to this diagonal, but these 2 points are also inverses of each other, because remember what we learned last class? If I have the original and I switch the x and the y, that gives me the inverse. So graphically, this is what it looks like. Let's pick another point. Let's say I picked, let's pick this point here. What are the coordinates of that point? Well, it looks like it has the coordinates -6 and +5. Okay, what do I get if I switch them? If I switch -6 and 5, I get 5, -6. So I'm going to go 5, -6 is this point over here. Okay, so if I check to see, how far is this point to the line, it should be the same distance and direction as that point. So both of these points are the same distance to this diagonal, and they're a reflection. Right? If you think of the diagonal as the mirror, the blue point is reflected and the mirror image is the red point. The blue point is reflected and the mirror image is the red point, and so on. So when we're looking at inverse graphs, we're looking at this relationship. But like I said, we're going to focus on continuous functions. And so we're going to graph a couple of them, and there's some steps below, but I just wanted to show you what a continuous looks like, right? So if I pick this point, it should be the same mirror image, and it's actually the same distance away. Right, let's look at another point. Let's say this point and this point. Again, they are the same distance away from the diagonal. So again, if the diagonal is like my mirror image, or if the diagonal is like my mirror, then the blue and the red are reflections of each other against this mirror. Okay. Okay. So now let's look at actually let me see if I can zoom in here as much as I can. We're going to look at a couple of different types of functions, and let me see if it's centered. That's good. I think that's pretty good. Okay, so the first steps that we're going to do when we're solving these examples is we're going to find the inverse algebraically like we did last class. Then we're going to sketch the line f of x equals x. This is the reflection line that we're going to use dashed line. This is the purple, that purple line that you saw in the graphs above. This is going to be the reflection line. Okay, then we're going to graph the original function, and I like to use blue for the original, and then we're going to graph the inverse function, and I like to use red. And keep in mind, use the same color. Use the same color for your originals. I'm going to use blue, and use the same color for your inverses, and I'm going to use red. Okay, so just make sure you use the same color. So let's look at this this first example. Let me slide up, and let me fix the spacing here. And there we go. Okay, so step one is find the reflection. Find the inverse. So if we use the steps from last class, let me use black. You change f of x to y. Then you switch x and y. Right? Step 1, step 2. Then step 3 is solve for y, so working to get y by itself. So I'm going to add 6 on both sides. I get x plus 6 equals 2y. The 6's cancel. Then the opposite of multiplying times 2 is dividing by 2. These are going to cancel. I'm going to be left with y equals x over 2 plus 6 over 2. And then I can rewrite this as 1/2 x plus 6 divided by 2 becomes 3. And then I can write it as f inverse of x equals 1/2 x plus 3. So remember I said I was gonna color code, right? So the original function I'm gonna graph in blue, and the inverse function I'm gonna graph in red. Okay. Step 2 says to sketch the reflection line using dashed lines. Okay, so I'm going to get my ruler and sketch the reflection line. But actually, I'm going to try it without a ruler. Okay, so this is my reflection line. It's just the diagonal. The line y equals x is the diagonal across the x and y axis. Okay, so let me graph the blue line. How do we graph a line like this? Well, remember, it's in slope-intercept form, so we know that right now we know that the slope is 2 and the y-intercept is -6, and this 2 is a 1. There's a 1 under the 2, so that tells me to go up and to the right. And my starting point is going to be at -6. So I'm going to put my first point at -6, and then the slope tells me to go up 2 and to the right 1. So right there. And then now I am going to use the ruler for this one. Okay. Now let's graph the inverse. So the inverse tells me a couple of things. Up here I'm going to say that it tells me that the slope is 1/2 and the y-intercept is 3. So the slope tells me to go up 1 to the right 2. But my starting point is going to be at 3. So I'm going to put my first point at 3. And then I'm going to go 1 up to the right 2. That's my second point. Then I'm going to use my ruler to graph the remainder. Like this. Yeah. Actually, let me draw it one more time, because I want to make sure that I get a certain point down. Because if I miss that point, then it's not going to look like a true diagonal. So let me see. Yeah, that's better. Awesome. Okay, so the point that I wanted to bring out is actually this point right here. So if I circle it, compare it to this point, these 2 points are the same distance away to the diagonal. There's 1, 2.5, 1, 2.5. So I just wanted to point out that extra point there, just to kind of confirm that the red and the blue are inverses. So how do we know that they're inverses? If I just look at the graph, this diagonal is going to cause a reflection. The blue is going to be reflected across the purple to form the red. Okay. So we're going to practice this again. Let's go over to example 2. So we're going to solve for the inverse. Step 1 in solving the inverse algebraically, change f of x to y. But let me stretch this out a little bit more. There we go. Okay, change g of x to y. So I'm going to change that to y. It's negative 1/3 x plus 2. Then switch the x and the y. And then solve for y. So the first thing I want to get rid of is the plus 2. So I'm going to subtract 2, subtract 2. I get x minus 2 equals negative 1/3 y. So what's the opposite of dividing by a negative 1/3? Multiplying by a negative 3. So on the left here, I'm going to distribute so negative 3 times x is negative 3x. Negative 3 times negative 2 is positive 6. The negative 3 and the negative 1/3 are going to cancel, leaving me with y. And I'm just going to rewrite it in the following way. Then I'm just going to write the inverse function is equal to negative 3x plus 6. So this is my inverse, and this is my original. And actually, I don't want to write f, I'm going to write g. G because the original function had a g, and so I'm going to use g for the inverse. And so then the next thing we would graph is the diagonal. I'm going to use purple for that, but just going to go across the diagonal here. Make sure it's a dashed line, not a solid line. Okay. Now let's graph the blue one. And so the blue one tells me that my slope is negative 1/3 and my y-intercept is 2. So the slope tells me, the negative 1/3 tells me to go down 1 and to the right 3. And the 2 is where I'm going to start. So I'm going to go on the y-axis and start at 2. So I'm going to put my point right here. Then the slope tells me to go down 1 to the right 3. Awesome. And then I'm going to get my ruler. Let's see. Okay. That's pretty good. Okay. And then let's see what the inverse tells us. The inverse tells me that my slope is negative 3 and my y-intercept is 6. But the negative 3 has a 1 underneath, so that tells me to go down 3 and to the right 1. But my starting point is going to be at 6, so I'm going to go up here at 6, my first red dot. Then I'm going to go down 3, 1, 2, 3, and to the right 1. and then I'm going to graph with my ruler. Awesome. Yeah, so you can see actually, like for example, these 2 points here are reflecting across the diagonal across the purple. And so, but even if I don't circle those points, right, and we just look at the blue and the red there, do you notice how the purple dashed line kind of works like a mirror, right? So, if I give you an equation, you can do the steps to get the inverse. But if I give you a graph, you should be able to identify if those graphs are inverses by drawing the diagonal line and checking to see that there's a reflection of some sort across this diagonal line. Okay. Let's go over to example 3. Now for example 3, I'm graphing it on my graph paper like I've done before. So this is how it looks for me. Right, so just graphing it on my graph paper. And first thing is we're going to solve for the inverse. So I'm going to switch the h of x to a y. Copy everything else like what we did last class. Then switch the x and the y. And then solve for y. So the opposite of adding 3 is subtracting 3. So I get x minus 3 equals the cube root of y plus 4. These 3's will cancel. How do I get rid of the cube root? Well, I need to put a parentheses on both sides and raise it to the third power. So I'm going to end up with x minus 3 to the third power equals y plus 4 because the cube root and the cube cancel. Then to get y by itself, I'm going to subtract 4. 4 minus 4 on the right cancel. So I'm left with y equals x minus 3 to the third power minus 4. And then to write it as an inverse, to write it as an inverse, I lost my train of thought. Okay, there we go. Minus 4. Okay, so what I got here at the end is my inverse function, and at the very beginning over here is my original function. All right, the next step would be drawing the diagonal as a dashed line going that way and this way. All right. Now we're going to graph but we're going to use the rules of transformations, because if you remember when we did transformations, we would graph cubic functions and cube root. And so if you remember, right, the plus 4 means we're going to go to the left 4. And the plus 3 means up, right? Up 3. So I'm going to graph it in blue. And so I'm going to go to the left 4. 1, 2, 3, 4. And up 3. 1, 2, 3. Which is about right here. And the cube root function has a particular set of points that does the following. If you remember, it does these points. And then it goes 8 and up 2. So I'm going to go 1, 2, 3. Do it with my pen here. 1, 2, 3, 4, 5, 6, 7, 8, 1, 2. And the other way, 1, 2, 3, 4, 5, 6, 7, 8, 1, 2. 2. And then so we graph the following function. So that's the original function. Now I'm going to graph the inverse. So the inverse is a cubic function that says to go to the right 3, and the minus 4 tells us to go down. So I'm going to go to the right 3 and down 4. Should be right here. So again, if I go to the right 3 and down 4, that's kind of like my starting point. And then I'm going to graph the cubic. And it's and so I'm going to go 8 up and 8 down. Right. So 8 up would be 1, 2, 3, 4, 5, 6, 7, 8. There. And then 1, 2, 3, 4, 5, 6, 7, 8. Down here. Wow, so I barely made it so that it's visible on the bottom there. All right. So again, to recap, right? The original is a cube root, and the inverse is a cubic function. And the cube root moved to the left 4 and up 3, and so that was kind of like my central point. And so I kind of created the general image of the cube root from what we remember from transformations, right? And then the cubic went to the right 3 and down 4, so I went to the right 3 and down 4, so that was kind of my central point. And then looking at the graph in general, do you notice how the diagonal is kind of a reflection point? So again, you know, if I pick this point and this point that I'm circling, and I measure, you know, how far is that distance from the point to the purple line, it should be the same distance if I go to the red to the purple. So they are essentially, you know, a reflection distance away. Actually, you know what I should do? Let me make it in a dashed line form so you guys can see that it's not definite, but it's just kind of showing you the distance between those 2 points and the purple line being the reflection line. Okay. So let's do one more example. All right, so example 4, let's solve for the inverse. So I'm going to switch the h of x to a y, copy everything else. Then I'm going to switch x and y. So it's going to be x equals y minus 2 to the third power minus 1. And now we're going to solve for y. So I want to get y by itself. So I need to move the 1 first. So the opposite of minus 1 is plus 1. I get x plus 1 equals y minus 2 to the third power. Then the minus 1 and the plus 1 right here will cancel. Then to get rid of the cube power, I need to cube root both sides. So I end up getting the cube root of x plus 1 equals y minus 2, because the cube root and the cube cancel each other. And then to solve for y, I'm going to add 2 and add 2. And so these 2's are going to cancel, and I'm going to be left with y equals the cube root of x plus 1 plus 2. Right, the cube root of x plus 1 plus 2. And then the last step is to replace the y with the inverse function notation. It's x plus 1 plus 2. And so this is my inverse. And over here is my original. There we go. All right, so if we graph, we're going to graph the diagonal. Okay. And so let's graph, and let's keep in mind that the original is a cubic, and now this time the inverse is a cube root. And the original cubic one has a x minus 2 inside, so that means we're going to go to the right 2, and the minus 1 is saying to go down 1. So I'm going to go to the right 2 and down 1. Right, to the right 2, down 1, that's my starting point. Then I'm going to graph the cubic function. So the cubic function has these points going 1 up, 1 down, right? Then the cubic function goes 8 down this way and 8 up this way. So if I graph that, it's going to be 1, 2, 3, 4, 5, 6, 7, 8. And then going up 1, 2, 3, 4, 5, 6, 7, 8. Right about here. Okay, so I'm going to connect it. All right, and then looking at the inverse down here, the plus 1 tells me to go to the left, and the plus 2 is outside, so that tells me to go up. So if I go to the left 1 and up 2, I'll end up right there. So this is kind of like my central point. The cubic, if you remember, has these extra points on the side here. This is my central point. It goes 1 up and 1 down. And then for the cube root, remember it goes down 2 and to the left 8, and then up 2 to the right 8. So I'm going to count my steps that way. 1, 2, 3, 4, 5, 6, 7, 8. It's about here to the left, and then I'm going to go 8 to the right. It's going to go 1, 2, 3, 4, 5, 6, 7, 8. Something like that. And then I'm going to connect it like that. And like that. All right. So that brings us to our last example. And I'll see you guys in class, and we can discuss then, any questions you have on the algebraic part or the graphing part. But I really like this lesson. It has a lot of everything kind of what we're thinking of in the class. It has algebra solving, and it has graphing combined in one problem. So yeah, so thanks for joining me today. See you guys in class.